So good afternoon, and this is session 7, the lesson on index numbers. So we would today seek to understand what index numbers are and why we even need index numbers to represent certain situations. Then we will do some minor computations that revolve around index numbers or indices. Okay. So as we get into it, you'll get to see the hang of everything gradually. All right, so an index number is a number that compares the value of a variable at any given point in time with its value at a fixed reference point. Okay, so we use index numbers to make certain comparisons to tell us the change or the percentage change in a situation. We have situations like, or issues like inflation, consumer price index, producer price indices. Now, these are economic indicators that help to determine certain issues in an economy. So if you take inflation, inflation generally tells us the rate of change in prices over a period, or how prices are changing over a certain time period. Oftentimes, we present these situations in percentages because they offer a more, let's say, a better understanding or less complex way of seeing these situations as they occur. So take an example. If you were to meet a statistician and you ask him, so how is our GDP performing? And he tells you, okay, so in 2019, we had 8,431,772,000, 0.001 hundred and something pesos. Okay, and in 2020, we have 15,941,000,123. These presenting information with raw figures or raw values like this sometimes make it quite cumbersome for us to appreciate the clarity or understand how situations are panning out in a certain instance or in a certain jurisdiction. So in business sense, we use index numbers or the index numbers to measure the percentage change in the value of a commodity over a time period, or not necessarily a commodity, but other instances like so. But oftentimes we present the issue of when we talk about index numbers, actually, oftentimes they represent changes in commodities, and it changes reference to price and then quantity. Okay. All right. So now, when doing this comparison, there is always a certain fixed period we call the base period or the base point. Now, there is a certain period against which we will compare all other periods, okay? So let's say if we want to make a comparison of what has happened over the past decade, let's say between 2010 and 2020. So that's a period of 10 years. So over the decade, we can choose 2010 as the base period. When we say 2010 is the base period, and this means that we would compare all the other years against what has happened in 2010. So 2010 is our base period. So we'll get into these and you'll see it. So let's start by getting a simple understanding into simple index number constructions. Okay, so for now, let's look at the case of percentage increases in certain occurrences. Suppose that the price of Coke, okay, in January was 2.0, in February was 2.2, and then in March, 2.8. Now, let's assume January is our base period. If we say January is our base period, then the understanding is that we are going to compare all the other periods with January. So if January is our base period, then we can, if we want to compare what's happening or what happened in February to January, then we will take the difference between the prices in January and February and divide by the price in January. So this is what we call the base price or the base value, the base price. And this would be the current price. Okay, so the current price. Okay, so the difference between the current price and the base price and the base price would give us the percentage change, okay? So in this case, we have a 10%. What this means is that between January and February, the price of Coke has increased by 10%, okay? If we do the same for March, then you would see that we have a 40% increase in price. Now, oftentimes when these things are told to you in the raw numbers or actual values, they do not really actually make sense. Look at two scenarios. If you went to the market and usually maybe you're coming to school at the beginning of the semester and you buy a cup of sugar for 2 cedis. Then maybe in the middle of the semester, 3 months or 4 months going on, you go back to the market to buy sugar again. And this time they tell you the cup of sugar is 2 cedi 80 pesos. 2 cedi 80 pesos. Well, it's only 80 pesos. It's less than 1 cedi. That's all. That's fine. You purchase it. But if someone came to you and said, I went to the market and can you believe in a space of 3 months, the price of sugar has increased by 40%. That gives a certain volume of understanding regarding these kind of issues. One, it brings some clarity and conciseness in terms of representing these issues. The other one of it is it gives you a clearer understanding of the thing. You get to move away from the actual values and look at the percentage change in the occurrence. Okay, so these are some of the things that we are going to use index numbers to do to help us understand. Again, if you take a phenomenon like inflation, if the Ghana Statistical Service would come telling us that, so if you go onto the market, the price of tomatoes in January was maybe a bucket of tomatoes was, let's say, 30 cedis, and a bucket of tomatoes is now 45 cedis. Or a basket of orange was 10 cedis, and now it is 50 cedis. Now, oftentimes, well, you're just looking at the money. But if someone told you that now in January, a basket of orange was, or between January and December, the basket of orange has increased by 500%. You open your mouth, say, what? 500%? That's like 100, 10, 10, 10, 5 times. Say, yes, that's the price. So these things give a certain amount of clarity to economic indicators, especially within price and quantity. So in understanding the concept of, or in doing the basic computations that we'll be doing, we will have some notations that we would want to use, okay? So if you see price P naught, P0, this represents the price at the base time. If you see Pn, it represents the price at some other time point, okay? So whatever time point we are interested in, that would be Pn. Q naught and Qn do the same, just that this time it is quantity at the base period and quantity at some current or other time point. IP is the price index and IQ is the quantity index. So if we have this expression, then to find your price index, it is the price at a certain time point, maybe a future time point, over the price at the base time or the base time point times 100. It will give you your index number. And the same applies for the quantity. So suppose that we have this expression here. So if I have this data here, and we say assume that the 2010, okay, is the base period. 2010 is the base period. If you want to compute the index number for each, or you want to compare each period and see what's happening over time, at the base year or the base period, the index number is always 100%. And I presume we can all understand, because at the base year, the current price and then the base price are the same. Okay, so it's just like saying Pn and Po will be the same. So here it is 50 over 50 times 100. Okay, and it gives you 100. So that's why at the base year or the base period, the index number is always 100. But at another time or at a certain different time period, you could have all sorts of values for your index number. So for instance, in 2011, the index number 2011 is, now 2011 is the new period we are looking at. So we'll call this Pn. and 2010 remains P naught because that is the fixed base period. Okay, so here you're going to have 60 over the amount, the price at the base period over 50 times 100, and that is 120. If we come to 2012, it is 55. So 55 over 50 times 100, it gives us 110. And this applies to all the other periods. So you notice that we compare each period to the base period. So this comes to this, we compare this to this, we compare this to that, and we compare this to this. Okay, so that gives us the general understanding for computing price indices. It is the price at a certain time period of interest over the price at the base time period multiplied by 100. Please have that in mind. If it is for quantity, then it is going to be the quantity at a certain time period of interest over the quantity of the base period times 100. Okay, so we all have this at the back of our minds. All right, so there are instances where we are interested in only a specific product or a specific output. So when we talk of an index relative, given a set of products, okay, we could or we are interested in finding the index chain or the index number of a specific product. And when that is the situation or a single distinct commodity, we say we are computing the index relative. So think about the fact that, for instance, if we have certain, let's say Accra Breweries Limited, or yes, let's take Accra Breweries, that has Malta Guinness and probably has the Baltic water and also has a barrel. Okay, so these are three, let's assume these are three products that come from this same manufacturing point. However, we want to see what is happening regarding the change in the price of our barrel. So in that case, among these three, although we could compute the index number for all of them, we are interested in only our barrel. So in that case, we are looking at an index relative to our barrel. Okay, so let's take an example here where we have a video recorder and a television set. Okay, this is the price. So let's assume 2013 is the base period, the fixed base period. And so 2012, now 2014 becomes that new period. Okay, and so the price at 2014 becomes PN, and the price at 20 is, and the quantity also becomes QN. Okay, so given this expression, we can find the price index and then the quantity index for a specific relative to one of the products. So for instance, if you're interested in video recorder, then it is the price at the current period where we are interested in, this is 542, divided by the base price, which is 500, multiplied by 100, and we have this. And if we were for quantity, then this becomes the quantity at the current period divided by the quantity at the base period times 100, and it gives us that. Now, because we have said that the base period always has an index of 100, any value higher than 100 shows an increase. So if I have, let's say, 110, it means between these two periods, there is a 10 percentage point increase. If I have 130, this means there is a 20 percentage point increase. So here, if I have 108.4, this is an indication there's an 8.4 percentage point increase in price. Okay. So in the instance where you have a value less than 100, this means that you have a price for, okay, a price for or a quantity, a fall in quantity, one of either of them. All I just need you to understand is once it is less than 100, it means there is a fall in the direction is a reduction. Okay, so here we can say we have a 30-point percentage decrease in quantity. Okay, percentage points decrease, not percentage. Okay, so the same applies to if we were interested in the television set, then we can find the price index of the television set and find the quantity index of the television set. So we have seen the instance where we have a fixed based relative index. Now, there could be some instance, although very rare, where we could have our base period changing. Now, in a situation where we have our base period changing very frequently, then we would say we are employing a chain-based relative indices. Okay, now it says, for instance, indices is usually expressed relative to a fixed reference point. So we always have a fixed or a base period against which we make our comparison. But in certain instances that are very rare, the indices could be expressed so that the reference time point or the base period for the current period is the immediate past period. So the period that immediately precedes the current period becomes the base period. In such rare instances, then we say the relative index is chain-based. Okay, so let's get into an example and see how this pans out. So let's look at there are two portions there, the top part and then the down part. Let's first look at the case of a fixed base relative index, which I'm sure we are all familiar with so far. And then let's look at the case of a chain-based relative index. So suppose we have this data here, and we assume that February is our base period. If we assume February is our base period, what this means is that we are going to compare all other periods to February. So all other periods, the value in all other periods will be divided by the value in February. So let's start. In January, we have 4563. Now, so this becomes our PN. This is the current period of interest. And then this February will be our PO. Okay, so then we have 4563 divided by 4245 times 100. It gives us our index number. In February, our index number is going to be 100. Okay, please ignore the percentage sign. It's not supposed to be the case. Okay, forgive me. Just noticing this. All right, so it is not supposed to be. You just have the index number. So at February, we have 100 as our index number. In March, the index number here would be 4841 divided by 4245 times 100. In April, we'll have 4644 divided by 4245 times 100. In May, we would have 5290 divided by 4245 times 100. And then in June, we have 5156 divided by 4245 times 100. So you would observe that for all the periods under the under the fixed base approach, our denominator, okay, or the P naught is the same, and that is the reference point. So here we have P naught over PO times 100, and that gives us the price index. Okay, so for the fixed base, the base value is the same, and all other periods are compared against the base value. All right, Kingsley Asante, you have a question. Please go ahead.
Sir, please, when we started, you were comparing the prices. That is, you compare the current price and you subtract the current price from the old price and you divide it by the old price times 100. But it seems like as we are going on, you are not subtracting it from. You don't do the subtraction.
Yes, the first instance,
I don't know whether
I said we were finding the percentage difference, okay, or the percentage change. Look at it here. Okay, so here we are looking at the percentage increase or decrease depending on what it happens. Okay.
Okay.
But the index number is not reporting the percentage increase. That's why when I was saying it, I said it is a percentage point increase. Okay. Right?
Okay. Okay.
All right. So that's what I was doing at first was just to find the percentage difference between something happening at certain points and then certain point. But for index numbers, we are comparing, this is stating it in index number form. And so we do not find that, we are not interested in the percentage difference.
Okay. Thank you.
Thank you, too. All right. All right. So Having sorted that out, the second instance is the case of the chain-based relative index. So for the chain-based relative index, we assume that the period that comes just before the current period of interest is our base period. So for instance, if I am interested in February, then January will be used as the base period. If I'm interested in March, then the value at February would be my base period. If I'm in April, then the value at March is my base period. If I'm in May, then April becomes the base period. Then if I'm in June, so this gives it some loop, some recurrent loop or recursive loop. And that's why we refer to it as a chain-based approach. So if you come here, you notice that we are unable to compute the index number for the period January. The reason being that we do not have data from the previous period, let's say possibly December from the previous year. So we can't compute the index number for January. But however, when we get to February, then February becomes the new period of interest. So here, February now, relative to the chain-based approach, the February becomes the new PM, the new period, and then January would become our base period. So you see 4245 divided by 4563, and we have our index as of February. When I move to March, if March is now the new period, then the base period becomes the value of February, okay? So now I will divide this by this, and I have times 100, and I have the index. If I go to April, then April is now my new period. March now becomes my base period. I hope you understand. All right, but just note that the ideal situation or the norm is to use the fixed base relative indices, okay? So we would continue using the fixed base as a standard, not the chain based. All right, so there are instances where we seek to compare values at different points. And when I mean values, we want to compare the index numbers at different points. So we want to compare the actual production values at different points. Either ways, we should be able to do that computation. And so all we do is to do some basic manipulations of the expressions we already know, okay? And in that case, based on certain assumptions, we should be able to do our comparison. So let's think about something here. Suppose I have this expression, IPN equals PN over PO. Now, this is the same as PN is the value at period N, and then PO is the base value, okay? The value. Now, if I have PM, let's assume PM is another, so PM over P naught, okay? Now, think about this. So it is feasible to make these comparisons because the base period is the same. Now, let's come here. You see, I can compare what has happened in April and May because I know that the base period is the same. Okay, you just need to tell me. So between April and February, this is the situation, and then between February and May, this is the situation. And so we can tell the percentage points differences in stuff. So what happens? So how are we able to make this comparison? This is the idea. Mathematically, we have this expression as this. Now, given the two expressions, there is one common term, which is P naught and P naught. Okay, that is the fixed base. And then the fixed base, it is common to both of them. This is like saying that I am interested in, let's assume PM is the current period, and I want to, and a future period or another point that I want to make the comparison, maybe is June. So I can call this PN, and this will be my PM, okay? Now, given this expression, PO is the same, is the how do you call it? The base period is fixed. So this is common to this and this is common to that. So we can make this the subject. If I make PO the subject, this is like saying I divide, this has a denominator of 1, I cross multiply, okay? So this is, at the end of the day, is going to be PN over IPN, okay? And If I do the same for the other one, PO equals, it would be PM over IPM, okay? So what this is trying to say, this is the same, this is equal to this. So under normal circumstances, I can comfortably say that PN, okay, over IPN is equal to PM over IPM, because P naught is the same as P naught. The how do you call it? The fixed base, the fixed period is the same. Now, if I have this expression, then I can easily make the comparison. If I knew the value at the certain future period, and then its index and the index, the value at a certain current period, and then its index, I can try and make certain comparison. So let's see how we have an example like that. So suppose that we have this data over a 7-month period from month 1 to month 7, and these are their index numbers, okay? So we are not given the actual values, but we are given their index numbers. Now the question says, if sales in month 3 amounted to 240, what was the sales value in month 8 if its index is estimated at this point, okay? If its index is estimated. So this is the expression. We say sales in month 8, which is the future period we are looking at, and then the index in month 8, and then sales in month 3, which is the current period that we are looking at. So this is like PM, this is PN, okay? And this is like IPM, and this is IPN, okay? So we can make this comparison. We don't know the sales in month 8, so let's just call it sales in month 8, okay? Over, we're given an estimate of the index in month 8 is equal to then the sales in month 3. The sales in month 3, we were told is 240. And then the index in month 3 is here, which is 98. So we can easily compute. So this will be sales in month 8 times 98 would be equal to 240 times 109. Okay, and when because we're interested in the sales in month 8, we'll divide both sides by 98. So all this will be divided by 98. So when you find this, we have 267. So the sales in month 8 is 267, and the sales in month 3 is 240. Means that there has been an increase in the quantity sold between month 8 and then month 3. Okay. All right. There is an expression. When we take index numbers and we're interested in finding the percentage point change or percentage point changes, the difference between the index number at the base period and then the index number at the current period gives you what percentage points difference there is. So if the index at the base point is 100, and let's say in period 2, the index number is 120, then we know we have a 20 percentage points increase, okay? If you have, let's say in period 4, which is 108, then we know we have an 8 percentage point decrease. So guys, increase, sorry. So what if we have, let's say, let's assume we have another, let's say period 6, and here this is 80. Who can tell me what this means? Yes, Johnson, please go ahead.
Yes, sir. Please, there has been a decrease.
Yes. So here it means there is a 20 percentage point decrease in what's it called? Maybe price or quantity, depending on what we are trying. Okay. So this is just a straightforward concept. Nothing here to drew over. Now, there are instances where we could have our base period changing. Okay, and although we do not like the fact that base periods should be changing, there are certain situations that can make it difficult for you to continue using the same in what's it called, base period. So we would have to change it at some point. And so it says that an index should be reset whenever there is a significant change that makes the comparison with earlier periods meaningless. So the first one, for instance, in Ghana's history, our first base year used to be 1960, and that was when we attained independence. Okay. Then, so we used it from 1960. Then in 92, they changed our base period to 92 because in 92 we moved out. We became a democratic state. Okay, we started. We began the democratic dispensation. Then I think in 2006 we all woke up one morning. Those of you, if some of you were born by then in 2006 we woke up to the news that we are a lower middle income economy. Okay, we are no longer a third class economy or a lower income economy, but we are a lower middle income economy. So based on that happening or that event, our base period was changed to 2006 from 92. So I don't know if currently it has been changed, but I know that the last time it. So maybe till now it is still 2006 or maybe some other period, I don't know. But there must always be a certain good reason behind changing the base period so that it makes more meaningful sense. Another instance when we can change our index, our base period will be when the index value or the index rises so high so that it's becoming quite meaningless, or it makes it difficult to understand what things are occurring. Now, for instance, if you have a percentage point, let's say, like what we just calculated, if you have, let's say, your base period is 100 and you have 110 in a certain period, this is just 10 percentage points, what's it called, change. However, if you have a base, something that is 5,000, okay, the same 10 percentage point difference or increase is 500. So you tell someone that, oh, so we had a 500 percentage point change, and 500 percentage point changes, someone's like, oh, that is huge. Someone may be thinking that is 500%. In actual sense, that is just 10%. So in this instance, when we have situations like this, it makes it a little deceptive, or a little confusing sometimes, understanding these index numbers and then the percentage point differences. So when the index number goes so large, there is a good reason to reset everything and bring it back to 100 by choosing another change period. Okay. However, there are some disadvantages, or the main disadvantage with changing the base period oftentimes is the fact that it introduces a sharp element of discontinuity, and then it throws that it casts that dark shadow on whether why are we making the comparison and not considering certain period. Like for a typical example in Ghana's case is, I find it difficult to understand that whenever a political party is in power, they seem to want to compare their performance to what it was in a previous what's called government's dispensation. So typically, when NDC is in power and they are performing either poorly or better on a certain element or indicator, they say when we're in MPP's time, this was the situation. If NPP is in power and they are performing poorly or very well on a certain indicator, they want to compare it to what was happening during this era. This is not usually so beyond these two eras, let's say, so beyond if NPP is in power now and they are making comparisons to NDC being in power, what happens to those instances beyond the era in which NDC was in power? It doesn't give a fair comparison, a fair basis for making comparisons, especially economic indicators. We need also, oftentimes it is always best to have a base period and a very good reason why we are setting the base period or the base time points, so that all indicators or all performance changes would be compared to the base period. Then we can tell what is happening clearly as a country. Okay. So in the case of the changing the base of a fixed base relative index, we're going to apply a similar notion, but well, don't be too bothered about this whole stuff that I'm going to do. It's just trying to see whether you can see the light or see the understanding to the thing, but this is not the main emphasis. So just follow with what I'm doing. But so suppose that we have a certain old index. Okay, I have an old index. So think about it. Let's say we first had 1992. Then we go to 2006 and we change it. So now if we are comparing anything beyond 2006, ideally we should compare it to 2006. So if today we are making any comparison, you must take all the way back to 2006 and start comparing from 2006 all the way so that we can see year by year. We don't sit at one place and say, okay, so we are comparing it to what happened in 2012 and 2016 and how, okay? That doesn't help us as a nation. Now, however, we can also, in let's say in 2020 here, make a certain comparison to what the situation was in 1992. So we can have a current period that is being compared to the base period, its current base period, or probably compare it to an old base period. So let's call the very previous base period as the old period, and let's call the most current one as the new index. Okay, so let's say we were using 92, then we changed to 2006. So 92 is our old basis or the old base period, and then 2006 will be the new basis for the new index. Okay, so if that is the case, then using the old index at period n, using the old period, so when we are in 2020 and I want to compare something to 2022, so using the old index as 1992, then the value in 2020 would be, it will be the value in period n, which is the current period I seem to want to make my comparison, divided by the old base value. Then I would come here and choose the base value over this period because I am comparing 2020 to 1992, okay? If I want to use the new base value, then as in I want to use the new index or the new base period as the basis for a new index, then it is the value in the current period of interest of mine, let's say 2020, divided by the base value as at what? 206, okay? So it is possible that I can be in the current period and either use the old basis or the old base period as a basis for an index number, or I could use the new base period as the basis for an index number, okay? Okay, so we have this. Now, the only thing we can say is, one thing that can be common to both of them is again the base periods, okay, because that remains fixed, okay. Otherwise, the new periods of comparison will keep changing, but the base periods, once you select a specific base period, it remains the same. So we can make the base values, either the old or the base values, we can make them the subject. And if we do like we did, like I showed you in the previous example. All right, sorry guys. So if, like we did in the previous example, if we make the base period or the base values the subject, you're going to have the value in the current period, okay, divided by the index value. So if you're doing it for the old one, then you're going to have the value in the current period divided by the old index. And if you're using the new base value, you do the same. So we take a ratio of the old base value and then the new base value. And you're going to have a fraction on a fraction. Okay, so it's like the value in period n divided by the old index value at period n, all over the value in period n divided by the new index value at period n. So if you do this, so let's say value in period n, let me call it v small v n, over old index at period N. Okay, now if I take this, you will have to now reciprocate it. Okay, so you're going to have new index at period N over value in period N. So here we can have this cancel. Okay, so if that cancels, we will be left with the old base value over the new base value will be equal to the ratio of what is left here, which is the new index at period N over the new index at period N. Okay, so if we are taking two periods, I can do the same for period N and also do the same for period M. Okay, so we can directly see that if we do it for two periods, let's say period M and then period N, then we can compare both period M and period N, like we did in the previous instance, where we say that the base values are the same. So if the base values become the same, then you can take period N and period M, you compare them. So to compare the old and new indices, we would have an expression which has the old index value at period N over the old index value at period M should be equal to these. Okay. Could we please mute ourselves? All right. So let's try and see whether, just look at how straightforward this is. So first, let's look at it from one point. In one instance, when I want to compare, I want to make a certain comparison. So say the following indices relative to the base year of 1975. So we are assuming that this is 1975, this is the index. Suppose the base year is to change to the year 2004. Calculate the new indices using the new base year. So these values, okay, these values were computed based on let's say the indices or the value as at 1975, but now we want to employ 2004 as a new base value. So the only thing is, now we are going to use the value of 2004 as our base value and no longer use the value of 1975 as our base value. So just like we've done all this while, it is this value divided by itself, it gives you 100. So like I said, the value at the base period is always the same, okay? Then for all the other periods, this is their value divided by the value at the new base period, okay? So all of them divided by the value at 2004, it gives you the new index values. And everyone, it's still the same approach that you take this value, okay, divided by this as the base value, you multiply by 100. This divided by this. So here we are not making any comparisons yet. Let's look at the instance where, okay, so we had the instance where we want to compare two different periods. So let's say that we have a period, let's say 8 years, and then within the first 4 years, we were using this first index 1. Okay, and so let's assume that year 1 was the base period. We used it all the way to here. Then in year 5, we decided to change the base period from year 1 to year 5. So now we'll now be using index 2. So the new index would be computed based on the value at year 5. The old index was computed based on the values in year 1. Okay, so it says if the company had not changed to index 2, what values would index 1 have in year 6 to 8? So here it says, if we go back, it says that the old index value at period N over the old index value at period M would be equal to, so we were using the old index value, okay, at period N. Now we want to compare, we are moving from the old to the new. So it's going to be the new index value at period N all over the new index at period M. So here, straightforward, this is our old index, this is our new index. So here, the expression is to take 230 over 100 times the index at period M, which is this new, so we are at year 6. This is the new index at year 6. So here is times 125. Okay, I'm not sure what it gives you, but we've solved it. Then if we come to year 7, it is 230 over 100 times 142. Then if we come to year 8, it is 230 over 100 times 160. And these would give you, so it's the new index over what we say probably the old index. But however, you need to understand that once we are moving to the new point, the new index will be 100 because it's going to be that value over itself like that. The B part says, what values does index 2 have in years 1 to 4? Now, so now we are reverting from the new index to the old index because now it means that we want to find the equivalent of this place. Okay, so in this column, we want to find index 2. So here, all we're saying is now we will take the old index divided by its new index and multiply it by whatever the value is at a certain point. Okay, so now it's just like taking the reverse now. If you go back to the start, now you see we now have, because we are moving back, it is now the old index at the period over the old index at the period M. Okay, so Kwachi Joshua, you have your hand raised.
Please, can we go to the next slide, the one you just left?
Yes, please. Or behind.
Yes. You are taking 100 over 2.
Should I go for it here?
No, the other one. No, sir. The 100 over, yes, here.
Here, or the next one? This one?
The next one.
This one?
The next one.
Is that
yes,
it?
this one.
Yeah, okay.
Yes, that is it. You are taking 100 on 230, and you are taking year 1. I thought we are talking about year 5.
Oh, so we are at B point. Okay, so it says that, so we are only trying to compute the values at 1 to 4. Okay. Now, in year 5, this is where we used from year 1 to 4 the old index, and then from year 5 we changed the index to year 5, okay, and then started using the new index. So once we change the new index, the index number at that point would be 100, okay? But bear in mind that now we are reverting to the old index. Is that okay? So we are just taking.
Yes. So I was. So I was thinking we will start from the 4. Then when we get the 4, we will move on to the 3, then 2, then 1.
So you're okay. So the problem is the procedure, right? Okay, all right. Okay, so I guess I was just doing it because the question asked for 1, 2. But yes, okay, what you have said does make sense. It will make it easier for anyone to just follow here. So you can just 100 over 230 times 199. Okay, then it gives us the value here. Then we can have 100 over 230 times what's it called? So by the time we get to 100, we're only going to end up having the same value at that point. Okay, all right. Thank you so much.
Yes, thank you, sir.
Okay. All right, sure. Okay, guys. So that's just the only difference in computing. So once you are given a table like this, if we are to move from the old index to the new index, it is just the new value over the index at that point times the values at M. And then if we are to do the reverse again, so just we are moving back to the old index. So the old index over the new index, then times the value at M, or the index at period M, which is the existing period. This now becomes the new period we are interested in. So then we just do the exact same and we track backward. Okay. All right. So it has the exact same thing. Okay. So well, thanks for your idea. I think your suggestion makes it easier for us to follow.
You're welcome, sir. You're welcome.
I would have given you 1 point, but today I'm not happy. Okay, so. So maybe next one I'll give you a very hard question, and if you get it wrong, I take 7. If you get it correct, I give it.
Okay, sir.
Okay, guys. Yes. Okay, so let's take a short break. So because there's going to be a lot of things to do now. Please, when do you want to write your IA? And how many topics do you want us to use for the IA? So we are now at section 7.
Never.
Oh, my friend, stop that. You know we must write an IA.
Integration and differentiation.
You want to
say pass tomorrow.
That's 3 weeks.
Never.
No, we have
This Saturday.
we have 2 weeks. We have 2 more weeks coming, right? This is the 4th week. So for me, I was hoping we could write it in the 6th week. Okay. When all the others have written.
Would it be online?
Yes, it will be online. Very short though. You even struggle. Like 25 minutes or 30 minutes, you are done. Even 30 minutes is too long.
Oh,
One hour, 1 hour.
No. 1 hour. No.
how many questions?
Maximum 3 questions. So 3
Something as
questions.
short as 3 is dangerous.
3 questions, each carrying 10 marks. So it means they are going to be interesting
Dangerous.
questions. Then you just have it. You sit. So each question carries. Each question is 10 marks, 10 minutes. 10 marks, 10 minutes. So after 10 minutes.
No objectives. Online. Sir, no objectives.
No. I don't give objectives. But
Okay.
your
Sir, since it's so, how is the presentation to be done?
don't worry. When you see it on Sakai, you will know the instructions will be there. You will know how to do the presentation.
All right.
Please, your PA said that all fail.
Who said that? Who said you all fail?
Your TA.
Said the TA.
Oh,
Seriously, he
why
said
did
we
he?
all fail.
Why did he say that?
I don't know.
A lot of people
He's making
fail.
fun of us.
Maybe you made him angry, or he was joking.
Oh, no,
From the rest of the class. Like
He said he was
a
joking.
lot of people are
Then,
writing it.
then it's a joke. Oh, but that one is
Receipt.
true. But last year, okay, so listen.
He was
listen.
joking. He was only joking.
Yeah, he was only
Someone
joking.
told me that these are best.
You guys
Because
should listen.
last year there were like 600 and let's say approximately 670 people. You have like 130 taking a receipt, and that one it is because like the those who marked it were so generous. Like when people have so just so maybe he's just trying to tell you the reality. Okay. All right, so let's just put in a little effort. Make use of the TAs, okay? Go for the tutorials, ask questions, let them help you, so that you have this thing, okay? Otherwise, maybe what he's saying is true. I don't know, but I can say, okay? I just know that I don't like to fail students, but if you give me the opportunity to fail you, yes, you have what you deserve anyway. Okay. Right, so let's finish up. I'm very sure today we'll be able to finish this class. It's all right. So guys, let's forgive me just a moment. I am a little distracted. I need to check. Guys, just a moment. Okay, so all right, so in instances where we have multiple, let's assume that we have multiple maybe commodities that we want to find the indices for, okay? In those instances, we have certain ways of computing the index numbers. So we are going to look at two approaches. We have the mean or the average relative index, and then we'll also look at the simple aggregate relative index. Okay. Yeah. Okay, guys, could you please mute it? All right, so guys, so let's look at the first one. We would say the mean average relative index. Mean, or into bracket, average relative index. What this says is that it says sum of separate indices at period n over number of indices. All right, so what this is saying is, if you have multiple commodities, let's say commodity 1, commodity 2, commodity 3. So let's say we have Milo, we have milk, and we have sugar. Now, when you find the indices of these, so you have their base values and then the current values. Let's say, so I find the index of this and I have 110, I have 120, and I have 130. What the mean relative index is saying is sum these three values. So 110 plus 120 plus 130. So this two alone will give you 250 plus 110, and you have 360. So once you have found this 360 as the total of the indices or the index numbers divided by the average. So it's like you are taking the mean of all the index values, okay? All right. Then in the case of the simple aggregate index, what it's saying is that sum all the values in the period. So you take, so this is kind of like, if you have the three products, 1, 2, and 3, you take all their current values. So PN1 plus PN2 plus PN3, okay? So divided by PO1, PO2, and PO3, all times 100. So let's get into it and see how it works. So let's say we have this table. We have coffee, tea, and hot chocolate in 2013, 2014, 2015, okay? So now let's see how we would apply the relative mean index and then the simple aggregate relative index. For the relative mean index, first we need to find their indices. So using the fixed indices, let's assume 2013 is the base period. So given that 2013 is the base period, we can find the index numbers, the index values for each of them. So for 2014, it is 62 over 55 times 100, 32 over 28 and 274, 72. So we find this. So these are the index values for 2014. We do the same for 2015. Then when we are done, we take the average. So for 2014, we add 112.7, 114.3 plus 102.8 all over 3 because there are 3 index values. And we do the same for 2015. And so this becomes our mean relative index of the 3 commodities. However, for the simple aggregate index, what this is saying is sum all the, so for 2014, this is PN, the current value for, if we are comparing 2014 and 2013, this is PN for coffee, okay? PN for tea, PN for tea, and then PN for hot chocolate. Sum all these, so we sum all these, and we divide by the sum of these as well, times 100. So we do 62 plus 32 plus 74, these, divided by 55 plus 28, 72, and you have this, okay? Then for 2015, it's the same procedure. We sum all these, and we divide by the sum of all these, okay? And we multiply by 100. Please, are we okay? Everyone understands this, right? Very basic computation, nothing.
Yes, sir.
However, there are some limitations to the mean and then the simple aggregate index approaches. Oftentimes, we are unable to actually fish out those values or those commodities that actually perform better. Now, for instance, if there is a significant change in price in one of the commodities, okay, we would want to notice that for individual products, we want to account for those significant changes that usually would happen. But these procedures do not actually help us account for those kind of changes. It's more like just a blanket approach to, doing the stuff. So we want to look at a way in which, now, supposing things do change, or supposing there are some peculiar occurrences in the commodities or in the price of the commodities, we should be able to account for them. Okay, so for instance, if we have gold, silver, and bronze, or let's say gold, silver, and some aluminum or something. Now, the value of gold will not be the same as the value of aluminum. There will be significant differences. So we cannot just lump them all together and assume that what is happening to gold, is the same thing that is happening to the price of aluminum. There could be some significant changes. So in those instances, we want to look at two procedures. Oh, another problem could also be when they have different units. Some stuff in grams and kilograms and milligrams and all this kind of stuff. We can put all of them together and just have a blanket assessment. So we have in dealing with those problems, we have something we call the weighted indices, where we introduce weights, or the weights, they add some relative importance to the commodities that require to be given importance. So for instance, if I am having my class, a student who often answers questions in my class oftentimes would get a 1 point. And what that thing does is that these are students who contribute to the class. These are students who always are interested in what I'm doing. So they must be distinguished from those who are just passive in the class, okay? So how do we introduce the weights? We can, let's just go straight to it. It says for the weighted indices, we are going to apply the same concept from the mean weighted or average relative index, and then also the aggregated ones. But this time around, we are going to introduce weights. So the weights, it says that if you want to find the weighted mean relative index, it says that you will multiply each index number with its respective weights, and then we will divide everything by the sum of the weights. Okay, and also for the weighted aggregate index, we will multiply each of the units, okay, with the respective weights, okay, and divide by the sum of the values, okay, at the base period, also by the respective weights, and multiply by 100. So let's get into a question here. So let's say that we have year 1 and year 2, okay? Let's take year 1 to be the base year. And then these are the respective weights of the products, okay? So it has that order. So let's compute the mean weighted mean index. What the weighted mean index is, if you take product 1, we would find first find the index number for product 1, 24 over 20 times 100. Let's find for product B, we would have 51 over 55 times 100. For product C, we'll have 84 over 63 times 100. And for product D, we would have 34 over 28 times 100. So when we are done and we find these values, or what their indices are, we will multiply the index numbers by the respective weights. And when we are done, we will divide by the sum of the weights. For the weighted aggregate index, what this is saying is, before adding all of this and dividing by the sum of this, we will multiply each of the values by the respective weights, okay, and divide by the sum of the base values multiplied by the respective weights. So let's get inside it. So for the mean weighted indices, or the mean weighted index value, see here we have 120, 92.73, 133, and just a moment, I'm trying to mute somewhere. All right, so when you are done with these, we now multiply each of these indices by the respective weights. So we multiply this by 6, this by 4, this by 1, this by 8. And when you're done, we take the sum, okay, of this total here of these values, the index numbers that have been multiplied by the weights, and you divide by the sum of the weights, and the weights are 6 plus 4 plus 1 plus 8. 6 plus 4 is 10, 1 plus 8 is 9, that's 19. So you divide this value here by 19, and we have 115.56. Okay, so this gives us a better reflection of what is happening, because now it has been able to attach weights, and those ones that have performed well have been given some weights that's attributable to their performance. In the case of the the case of the weighted simple aggregates, what we do is you first take the PN values, you multiply each of the current values by the weights. So 66 times 24, 4 times 51, 1 times 84, and we find the total. Then we also go to the base values. Again, we multiply each base value by the respective weights, and we also find the total. So now you divide the overall total, 627, and you multiply by 100, and it gives you the aggregated weighted index. Okay, please, any question? All right, so you guys don't have questions. You're awesome. So we have two. Finally, we also have some indices, two indices that we call them. They are special indices, which also apply weights, but oftentimes here the weights are not predetermined weights like we have. Johnson, you have your hand raised. What's the question?
Yes, sir. Please, if you are asked to calculate for the weighted simple aggregate, do you have to go to the formula before you start the process?
You guys and this way of doing things. All right. Truth is, personally, from where I stand, I really don't care whether you quote a formula or you don't quote a formula. Okay. Because even in the exam, we ourselves give you the formula. There's a formula sheet attached to your question paper, and all the formulas you need to solve the question are added to the formula sheet. So if you write a formula, it's just like you reproducing what I have given you. Okay, so personally, I don't care where you have a formula. Okay. So you choose in between the lines. If you have too much time on your hand and you want to waste it by writing the formula, fine. If you don't, also no Allah.
Thank you, sir.
All right. Okay. All right. So we have these two special indices. Now, in these special indices, when you do not have when the weights are not predetermined, but we can use the price and then the quantities as the weights. So the first one is Las Paye price index. It's a French borrowed word in English. Okay, so Las Paye price index. With the Las Paye price and quantity index, we use the base quantities and then the base price as base price values or base quantity values as the weights. Okay, so please have this at the back of your mind. So for instance, if you're finding the Las Paye price index, okay, if you're finding the Las Paye price index, it follows the same procedure where we have PN, okay, I over our POI, meaning that there are several commodities, okay? There are commodity 1, commodity 2, commodity 3, so it moves from I to whatever number. But in this case, the base quantity would be used as the weights, okay? So we use the base quantities for the weight when you are finding the price index. And then when you are finding the quantity index, then you will now use the base price as the weight. Okay, so for the Las Paye price index, we have the quantity, the base quantity, multiplying the current price divided by the base quantity multiplying the base price. For the Las Paye quantity index, Then it reverses. We'll now use the base price multiplying the current quantity divided by the sum of the base prices multiplied by the quantity, the base quantity index. So let's get into it. Let's see if we have a question here. So we have this information here. This is the price at a certain period. So we can even use the year, let's say 2010 and 2014, 2010 and 2014. So let's assume 2010 is the base period. So the prices as at 2010 for product A and B, 10, 20, so this is it. And then at 2014, these are the new prices, and these are the quantities and stuff. So if you have to find the price index, the last price index, okay, price index, we are saying that for this case, you must use the base quantity as the weight. Okay, so what this is saying is you're going to take for product A, you're going to take its current price multiplied by the base quantity, okay? Plus, again, for product B, we'll have 25 and multiply it by the base quantity, which is 4. Then we divide by, you take the base, the quantity. Oh, yes, you're going to take the, the base stuff and multiply it by the base price. So here, you're going to have 95 multiplied by the base price. We remember, you know that the formula is Pn over P naught. So you come again to the base price. So the base price is 10. And then the base quantity still remains the same. That is still the weight, so you multiply by 95. Then again, the base price, you multiply by the base quantity, which is 4. Okay, when you're done, you multiply everything by 100. Okay, now if you're finding the quantity index for the last pi quantity index, then now you're going to do quantity n over quantity naught. But remember that the price naught would be the weight, okay? So here you're going to have, let's take quantity n is 100, we'll multiply it by the price naught, which is 10, plus the second one, which is B, which is 2, times where is the price naught, which is 20. Then we divide by, now we come to quantity naught, which is 95, multiplied by the price naught, base price, plus again 4 multiplied by 20. When you're done, you multiply by 100 and it gives you the price index. Okay, so that is it. That is it for the last price index. The other one
Sir,
is
please, I don't understand.
yeah, you have to understand. Look at what we have done. You can't just say, what don't you understand? Go back and look at what we have written here. We're saying that last price index, you know that the price index is Pn over Pi over Po, right? All we are saying is here, this is current price, so last price index, current price over base price. Use the base quantity as the weight. That's all. If you're finding last quantity index, we know it is current quantity over base quantity. Use the base price to be the weight. So what don't you understand? Hello, the one who said you don't understand, tell us what you don't understand. Okay.
Sir, please, the table that you were doing, it's confused me.
But that's the point. It has to be confusing. Even this one will intentionally give you, this is just 2 products. It will give you like 5, 6 products. So by the time you are done, you've confused the thing. The answer is wrong. And Sakai is also wrong. That's all. Or it logs you out so that it prevents you from entering the wrong answer. But I told you didn't I tell you the trick? That the trick is that I am looking for a way to make sure you get it wrong. You must look for a way to get it correct. That's just how life works. It's just straightforward in that manner. Okay, so think about it in that sense. Everyone is looking for a way for you to feel you are the only one who's looking for a way to prove them wrong. Okay. All right. So here, let's get to the second one, which is the Pache index. Okay, the Pache price index and then the Pache quantity index. The only difference here is, look, the first one is called last Pache base weighted index. So here we use the base values as the weights. Okay, when you come to the Pache, it says it is what? Current weighted index. So for the Pache index, this time around, it is the current, if you're computing the price index, the Pache price index, then you're going to use the current quantity as the weight. If you're computing the Pache quantity index, then you're going to use the current price as the weight. Basic stuff. Let's get into this table here. So here, let's assume that you are finding the Pache price index with this one. You have year 1, year 2. This is for the number of units. So consider this as the quantity. Okay, this is Q price and this is P. Now, if you are to find the Pache price index, it is Pn over P naught. But here, Pache is current weighted. So here you're going to use the current quantity, okay, as your weights. So here, if we're going to start, you're going to have Pn. So let's take this as the base period. So you're going to have this, okay, if this is the quantity, the current, so let's first break it down easily. This is the base, so this is the current. Okay, this is the base, this is the current. So if I am interested in the price index, I am looking at Pn over Po, right? So this is, all these will be Pns. So this will be Pn1, Pn2, Pn3 in that order. Okay, that's why the formula says Pi. This is going to be Po1, Po2, Po3 in that order. Okay, please, are we following? Then this is the quantity. So this is going to be the current quantity Qn. This is going to be the base quantity Q0. So if I'm interested in finding this, it says that take the current price, multiply it by the current quantity. Take the next one, multiply it in that order, and sum them. So here, you're doing Pni times Qni, which is going to be here, this is the current price, 11 times 24. We move to the next one, 25 times 51 plus 17 times 84, okay, in that order. And the last one is 20 times 34, okay? All over. Now we move to the base, PO. So all the PO against the same QN. So you're going to have 10 times 24 plus the next one is 23 times 51. Next one is 17 times 84. And the last one is 19 times 34. Okay, so we do all this, then you multiply by 100. That would give you the Pache price index. If you were to compute the Pache quantity index, then here, this is equal to Qn over Qo, okay? But because there are multiple products, there are A, B, C, D, we will say Qni, okay, where I goes from 1 to whatever number of products we have. Then you are going to multiply this by the current price. So this time you're going to have Pn as the weight. And because there are multiple PNs, you also have Pi. So it is summation, okay, summation, okay? So you take the quantity, which is 24, times the current price, which is 11, okay, plus the reverse. Now again, the second one is 51 times 25. The next one is 84 times 17. 34 times 20. Okay, and the next one you have, now you move to Q naught. This is Q naught still against the current price. So 20 times 11 plus 55 times 25 plus 63 times 17 plus 28 times 20. Then times 100. Then we can give you your partial price. Are we okay?
Yes, sir.
Yes. So
Yes, sir.
this is when, oh sorry, when I need you to find the last price index and the partial price index, and this, sorry, and the last quantity index. Here, this is the partial or the current weighted index for price, and then the current weighted index for quantity. Oh, this is beautiful. So, guys, are you following? This is awesome,
Yes,
right? All right.
Yes, sir.
Yes,
it is.
sir.
All right.
No,
So,
sir.
I think this is the last slide. So let me pause the recording.